Yes students, welcome to our second video lecture. Today we are going to discuss the topic of cumulative frequency and its corresponding cumulative frequency distribution. Students, pay attention. Today we are going to discuss the topic of cumulative frequency and its corresponding cumulative frequency distribution. Up to 10th standard, all of you have found out cumulative frequency for the sums of V. I hope that much is very clear. Now, suppose I have a discrete frequency distribution. A discrete frequency distribution is classification of discrete variable. Say xi is number of children and say fi is number of families having those many children. I have not written the description of variable. Xi is number of children and fi is number of families having corresponding number of children. Now students, if I want to find CFI, cumulative frequency which is denoted by CFI, cumulative frequency of 0 is 5, cumulative frequency of 1 is adding both these frequencies, so 5 plus 10, 15, cumulative frequency of 2 is adding of all this, so it is 27, 5 plus 10 plus 12, cumulative frequency of 3 will be 31, adding all these frequencies, and cumulative frequency of 4 is 30. So this is how students we find cumulative frequencies. Now pay attention. The first thing is the definition of cumulative frequency of a specified value of variable, say xi. Now cumulative frequency of 2 is how much? 27. How this 27 is obtained? It is addition of frequencies of all the values of xi which is less than or equal to 2. Check. 5 plus 10, 15 plus 12, 27. Cumulative frequency of 2 is sum of frequencies of all the values of x which are less than or equal to 2. Same way, cumulative frequency of 1 is, students, how much? Then I can say 15. It is sum of frequencies of all the values of x which are less than or equal to 1. So in general, if I am going to define cumulative frequency of a specified value of variable, then I can say the sum of frequencies of all the values of xi which are less than or equal to a specific value is called cumulative frequency of that specified value of variable. Try to understand this. If I want to find cumulative frequency of variable xi is equal to 2, then it is sum of frequencies of all the values of x which are less than or equal to 2. If I want to find cumulative frequency of xi is equal to 1, it is sum of frequencies of all the values of xi which are less than or equal to 1. So whenever students we want to define cumulative frequency of a specified value of variable, it is sum of frequencies of all xi which are less than or equal to that specific value. So the first definition, mind you students, this definition you have to very carefully understand and write. I am not writing the definition, you have to write the definition on your own. After after you study this lecture. So what is the definition? Once again, the cumulative frequency of a specified value of variable xi. How to define this? The sum of frequencies of all the values of xi which are less than or equal to that specific value is called cumulative frequency of that specified value of variable. Once again, the sum of frequencies of all the values of xi which are less than or equal to that specific value is called cumulative frequency of that specified value of variable. I can write here, for example, cumulative frequency of xi is equal to 2 is 5 plus 10 plus 12, which is nothing but 27. One more example. Cumulative frequency of the value of variable xi is equal to 1 is sum of frequencies of 0 and 1, which is 5 plus 10, and that is how many students? 15. So this is the definition of cumulative frequency of a specified value of variable. Now students, my second definition is cumulative frequency of a specific class of a frequency distribution. This is my second definition. Now students, I am changing my distribution from discrete to continuous. Let it be either inclusive students or exclusive, that will not matter. Say I will have to write classes and fi. Say 0 to 10, or let us write 0 to 9, suppose 10 to 9, 20 to 29, 30 to 39, and 40 to 49. So frequencies are 5, 2, 4, 1, and 3. Now I am finding first cumulative frequency 5 plus 2, 7, 7 plus 4, 11 plus 1, 12 plus 3, 15. Okay. Now, what is cumulative frequency of class 20 to 29, 11? It is sum of frequencies of all the classes preceding that class and up to that class. Cumulative frequency of class 20 to 29 students is 11. How this 11 is obtained? It is sum of frequencies of all the classes preceding that class and including that class. We have included the frequency of that class, which is 20 to 29. So, cumulative frequency of a specific class is sum of the frequencies of all the classes preceding above that class, including that class. So here, for example, cumulative frequency of class 20 to 29 is the sum of frequencies of all the classes above that class, including that class, which is 11. Same way, cumulative frequency of class 10 to 19 is sum of frequencies of the class above that class, including that class, which is nothing but 5 plus 2, and that is how much? 7. So first of all, students, you should understand what is cumulative frequency of a specified value of variable when it is discrete frequency distribution, and what is cumulative frequency of a specific class of a frequency distribution. Let that frequency distribution be either inclusive or exclusive, that doesn't matter. So I am defining cumulative frequency of a specific class of a frequency distribution. Pay attention. The sum of frequencies of all the classes above that class, including that class, is called cumulative frequency of a specific class of a frequency frequency distribution. Once again I am defining the sum of frequencies of all the classes above that class, including that class, is called cumulative frequency of a corresponding class. I hope now this should be very clear. Now students, cumulative frequency distribution are of basically two types: less than type and more than type. My next definition, students, pay attention. Our first definition was cumulative frequency of a specified value of variable. This was our first definition, so I am writing here 1. Our second definition, which you have to write, is cumulative frequency of a specific class of a frequency distribution. Clear? Now students, the third concept is there are two types of cumulative frequency distribution. One is less than type and the other is more than type. Basically, there are two types of cumulative frequency distribution. Types of cumulative frequency distribution. One is less than type and the other is more than type. This students you have to remember. This is our third concept, not third definition, but third concept. Basically, there are two types of cumulative frequency distribution. One is less than type and other is more than type. Clear? Now, what is less than type cumulative frequency distribution? Especially when a continuous distribution is there. All of you pay attention. What is less than type cumulative frequency distribution? Then you should remember like this. In less than type and the other is more than type. Correct? If classes are given in less than type, we use upper boundary points and corresponding cumulative frequencies. And in more than type, we use lower boundary points and corresponding cumulative frequencies. This students we have to perfectly remember. So once again, I am revising again and again all the theories. This is a very important topic. Our first definition was cumulative frequency of a specified value of variable. Our second definition, I am writing here D. D stands for definition. D stands for definition. Second definition was cumulative frequency of a specific class frequency distribution. Now my third concept, types of cumulative frequency distribution. There are two types of cumulative frequency distribution. One is less than type and other is more than type. In standard 10th we have studied OJAIs, less than type and more than type. Now, what is the definition of less than type cumulative frequency distribution, and especially for continuous, means when classes are there? A frequency distribution involving upper boundary points and corresponding cumulative frequencies is called less than type cumulative frequency distribution. I am talking especially for continuous when classes are given. I repeat, a frequency distribution. So this is our definition number 3. I am writing 3D, and this is our definition number 4. So I am writing 4D. So what is the third definition? What is the less than type cumulative frequency distribution when classes are given? A frequency distribution involving upper boundary points and corresponding cumulative frequencies is called less than type cumulative frequency distribution. Remember opposite. In less than type we have upper boundary points. In more than type, students, we have lower boundary points. So what is the fourth definition? More than type cumulative frequency distribution. Then the definition is a frequency distribution involving lower boundary points of classes and corresponding cumulative frequencies is called more than type cumulative frequency distribution. Remember opposite. In less than type we have upper boundary point. In more than type we have lower boundary point. So this was the third definition, students. This is the fourth definition. So once again, definition 3, less than type cumulative frequency distribution. A frequency distribution involving upper boundary points of classes and corresponding cumulative frequencies is called less than type, and more than type, a frequency distribution involving lower boundary points of classes and corresponding cumulative frequencies is called more than type cumulative frequency distribution. Then the next definition. What is a discrete cumulative frequency distribution? I am writing 5. Discrete cumulative frequency distribution, and the sixth definition is continuous cumulative frequency distribution. A cumulative frequency distribution of discrete variable is called discrete cumulative frequency distribution. And sixth definition, a cumulative frequency distribution of continuous variable is called continuous cumulative frequency distribution. So today's lecture is exclusively for concepts, and concepts, students, are to be perfectly understood and mastered. This is such a topic that it is always asked in exam. This topic, cumulative frequency, basically sums, and one definition is always asked in exam. So I am repeating definition 5. What is a discrete cumulative frequency distribution? A cumulative frequency distribution of discrete variable is called discrete cumulative frequency distribution. And the sixth definition, a cumulative frequency distribution of continuous variable is called, students, continuous cumulative frequency distribution. This, students, we have to perfectly memorize. So today's concept, students, we have done 6 definitions, and this 6 definitions, students, we have to very perfectly understand. So let us revise these definitions in nutshell. First definition, cumulative frequency of a specified value of variable. The sum of frequencies of all xi less than or equal to that specific value is called cumulative frequency of that value of variable. Second definition, what is cumulative frequency of a specific class of a frequency distribution? The sum of frequencies of all the classes above that class and including that class is called cumulative frequency of that specific class of a frequency distribution. Next concept was, this is not a definition, this is a concept. Types of cumulative frequency distribution. We have 2 types of cumulative frequency distribution. First is less than type and second is more than type. Now, what is the definition of less than 10 cumulative frequency distribution in classes are given? A cumulative frequency distribution involving upper boundary points and corresponding cumulative frequencies is called less than 10 cumulative frequency distribution. And a cumulative frequency distribution involving upper boundary points or lower boundary points of classes and corresponding cumulative frequencies is called more than 10. I repeat, in less than 10 we have upper boundary points and corresponding CFI. In more than 10 we have lower boundary points of classes and corresponding CFI. Then definition 5. A cumulative frequency distribution of discrete variable is called discrete cumulative frequency distribution. And definition 6. A cumulative frequency distribution of continuous variable is called continuous cumulative frequency distribution. Students, you have to understand and master this. Then students, we will be able to do sums. So in short, this topic of cumulative frequency and corresponding cumulative frequency distribution is very important from examination point of view. So students, I advise you to learn and write these definitions twice. Once you write in workbook, learn it, and then students, without looking, you should write it once in Fairbook. Then students, you will master these concepts. Now students, as today we have done only theories, let us check if we can do some BSK from section B. I think we have already done, but you can say let us do the first 5 BSK from section B. That also students, you have to write once in Fairbook and once in Rough. Now, what is the first definition? Define discrete variable. A variable which assumes finite or countable values within a specified range is called discrete variable. We have already discussed. Second, what is continuous variable? A variable which can assume any value within a specified range is called continuous variable. What is classification? The process of dividing ungrouped data or raw data into a systematic form or classes is called classification. This also students we have discussed. State the types of classification. State the types of classification. That also students we have discussed. There are 2 types of classification. Classification of qualitative variable or qualitative data and classification of quantitative variable or quantitative data. We have as such 2 types of data which we have already studied in chapter 1, qualitative and quantitative data. Based on that, we have 2 types of classification. Classification of qualitative data and classification of quantitative data. Define the frequency of an observation. Define the frequency of an observation. The number of repetitions of the value of an observation is called frequency of that observation. The number of repetition of the value of an observation is called frequency of that particular observation. Then 6. State the method to determine number of classes on the basis of range of the data. Class length. Number of classes, pay attention. I am writing here. Number of classes K is always range divided by class length. Number of classes is always range divided by class length. R is range, K is number of classes, and C is definitely class length. When should one form a frequency distribution with unequal class length? When the range of the data is a very large value, in such a case, one must form a frequency distribution with unequal class length. Then define cumulative frequency. You have to write both the definition. Cumulative frequency of specified value of variable also, and cumulative frequency of a specific class of a frequency distribution, because here it is not coded for what. So in 8 you have to write the definition of cumulative frequency of a specified value of variable xi, as well as cumulative frequency of a specific class of a given frequency distribution. So this 8 questions of section B also, students, you have to write. So here we are concluding this lecture. In the next lecture we will be doing the sums of cumulative frequency. Thank you, students.